Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Diffusion Models. How AI paints realistic pictures step by step. For a long time, AI has been great at telling us what things are, like identifying a cat in a photo or translating text. We call this discriminative AI. But what if AI could imagine and create new things? What if it could paint a cat, even when it's never seen before? Developers, imagine writing code that doesn't just process existing data, but invents new, incredibly realistic data. This is the world of generative AI. And today, we'll explore diffusion models, a key player in this artistic revolution. At its heart, a diffusion model works by learning how to undo a process of gradual destruction. Think of it this way. Imagine you have a beautiful, clear photograph. What if we slowly add more and more random static, like old TV fuzz, until the original picture is completely gone and it's just pure noise? The genius of diffusion models is that they learn to reverse this exact process. They learn to take that pure static and, step by step, figure out how to remove just enough noise to reveal a clear image. As developers, we can think of this as defining a forward function that adds noise, and then teaching a model to infer the inverse function to remove it. Before AI can create, it first needs to understand how things fall apart. In the training phase, we take millions of clean, perfect images. For each image, we apply a simple, predefined process. We gradually add tiny amounts of random, noise, static, to it, over many small steps. We do this repeatedly until the original image is completely obscured by static. Think of it like repeatedly applying a filter that adds a little more static, over and over, until the original image is completely gone. This isn't the AI doing anything clever yet. It's just us systematically generating ruined versions of pictures, and keeping track of exactly how much noise was added at each step. This is where the actual AI learning happens. We now challenge our AI. Given a noisy image, can you predict exactly what tiny bit of noise was added in the last step, so we can remove it? The AI is shown a noisy image and asked to guess the noise. It learns by comparing its guess to the actual amount of noise that was added, which we know from our forward pass. It's like teaching an artist to perfectly reverse the smudges on a canvas. We train a neural network, our AI model, to predict the noise component that was added, given a noisy image and the current time step, which indicates how noisy it currently is. The brain of our diffusion model is typically a specialized type of neural network often called a U-net. Don't worry about the complex architecture. Just know its job. This U-net takes two main inputs. 1. The currently noisy image. And 2. A time step value, which essentially tells it how far along in the noise adding process this image is, i.e., how noisy it is. Its output is a prediction of the specific noise pattern that needs to be removed from the image. To make it slightly clearer, think of it as a function predict noise, image with noise, time step, that returns the noise to remove the crucial piece of information for our reverse process. Now for the exciting part. Creating a new image. We start with pure, random static, a canvas with no discernible image. This static is essentially our latent space or starting point. We then repeatedly ask our trained U-net to take this current noisy image, predict the noise that shouldn't be there, based on its training, and remove it. This is done iteratively. Image equals image, model, predict noise, image, current time step, With each step, the image becomes slightly less noisy and reveals more structure. Repeat this process thousands of times, and the random static gradually transforms into a coherent, stunningly realistic image, seemingly conjured out of thin air. If the AI just generates any image from noise, how do we get a dog wearing sunglasses on a skateboard? This is where conditioning comes in. We give the AI extra input to guide its creation. For text-to-image models, like Stable Diffusion, we use another small AI model, a text encoder, to turn your text prompt, "dog wearing sunglasses," into a numerical representation called an embedding. This embedding is then fed alongside the noisy image and the time step to the denoising U-net. So, the U-net doesn't just predict noise. It predicts noise conditional on your text prompt. It's like telling a painter, "Draw me a dog," while they're sketching, ensuring the final image matches your vision. Diffusion models have revolutionized generative AI by producing images with unprecedented realism and detail, leading to incredible creative freedom. Their applications are vast, generating realistic art and design assets, creating stunning photo edits, augmenting datasets for other AI training, and even in fields like medical imaging to synthesize data. For developers, this opens up incredible possibilities. Building creative tools, automating visual content generation, or even designing virtual worlds with generated assets. It all stems from a simple, yet elegant, idea of learning to reverse a noisy process. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.